inside the atom. Matter is composed of molecules and molecules are made of atoms. Atoms are the smallest complex unit of matter. Historical background. Rishi Kanad in 6th century BC said that every object is made up of indivisible prime particles. He called it as Parmanu. A Greek thinker Democritus postulated that matter is made up of very small particles, that is, atoms. In 1803, A.D. John Dalton put forth atomic theory. Matter is made of small particles called atoms. Atoms cannot be created, divided into smaller particles, nor destroyed into the chemical process. Thomson's theory of atoms. John Thomson in 1867 developed the idea that atoms are made of negative electrons embedded in a gel of positive charge. Rutherford in 1911 demonstrated that the atom has a tiny, massive nucleus. Rutherford scattering experiment. Rutherford beamed alpha particles, that is, doubly charged helium ions, through gold foil and detected them as flashes of light or scintillations on a screen. In fact, he observed the following point. Most alpha particles passed straight through the gold foil. Some of the particles deviated at small angles. Very few bounced back towards the source. 1. An atom has a tiny, dense, positively charged core called a nucleus. 2. In nucleus, all the mass of an atom is concentrated. 3. The light negative constituents called electrons revolve around the nucleus in paths called orbits. Mass of electron is equal to 1 upon 2000 multiplied by mass of the proton. Mass of the proton is equal to mass of neutron. Niels Bohr's atomic model. Niels Bohr revised Rutherford's model by suggesting that the electrons were confined into clearly defined orbits. They could jump between these orbits but could not freely spiral inward or outward in intermediate states. An electron must absorb or emit specific amounts of energy for transition between these fixed orbits. Discovery of the neutron. John Chadwick in 1932 discovered another particle inside the atom called neutron. An atom consists of a nucleus which contains protons and neutrons. Electrons revolve around the nucleus in fixed orbits. Distribution of electrons in orbit. The orbit closest to the nucleus is given the number 1, the second orbit the number 2, and so on. They are also named as K, L, M, N, and so on, corresponding to the shell number. N is equal to 1, 2, 3, 4, and so on. The number of maximum electrons in each orbit is given by a formula 2n squared. Let us look at the table below. Shell or orbital symbol n, 2n square, and maximum number of electrons in the shell. Symbol k, number 1. 2n square is equal to 2 multiplied by 1 square. Symbol L, number 2. 2n square is equal to 2 multiplied by 2 square. Maximum number of electrons in the shell is 8. Symbol M, number 3. 2n square is equal to 2 multiplied by 3 square. Maximum number of electrons in the shell 18. Symbol N, number 4. 2n square is equal to 2 multiplied by 4 square. Maximum number of electrons in the shell 32. Electronic configuration of elements. The arrangement of electrons of each element in their orbits or shells is known as its electronic configuration. Electrons in the first orbit have minimum energy. The electronic configuration of atoms of some elements is as follows. Atom. Symbol. Number of electrons present in an atom. Configuration of electrons in shells. Symbol and maximum capacity. And lastly, numerical representation of electronic configuration. Atom hydrogen, symbol capital H. Number of electrons present in an atom 1, K 1. And numerical representation only 1. Atom helium, symbol capital H small e or He. Number of electrons present in an atom 2. Configuration is 2 and numerical representation is also 2. Atom lithium, symbol Li. Number of electrons present in an atom 3. Configuration of electrons is 2, 1 and numerical representation is 2, 1. Atom carbon, symbol C. Number of electrons present in an atom 6. Configuration 2, 4 and numerical representation 2, 4. Atom nitrogen, symbol N. Number of electrons present in an atom 7. Configuration of electrons 2, 5. Numerical representation of electronic configuration 2 and 5. Atom oxygen, symbol O. Number of electrons present in an atom 8. Configuration 2, 6. Numerical representation 2, 6. Atom fluorine, symbol F. Number of electrons present in an atom 9. Configuration of electrons 2, 7. Numerical representation 2, 7. Atom neon, symbol Na. Number of electrons present in an atom 10. Configuration of electrons 2, 8. Numerical representation 2, 8. Atom sodium, symbol Na. Number of electrons present in an atom 11. Configuration of electrons 2, 8, 1. Numerical representation 2, 8, 1. Atom chlorine, symbol Cl. Number of electrons present in an atom 17. Configuration 2, 8, 7. Numerical representation 2, 8, 7. Atom argon, symbol Ar. Number of electrons present in an atom 18. Configuration 2, 8, 8. Numerical representation of electronic configuration 2, 8, 8. Atomic number and atomic mass number. Atomic number Z is the number of protons present in an atom. An atom of an element is electrically neutral. Atomic masses are measured in a unit called Dalton or U. 1 Dalton is equal to 1.6 multiplied by 10 raised to minus 27 kilogram. 1 proton is equal to 1 U. 1 neutron is equal to 1 U. 1 electron is equal to 0.0055 U. Atomic mass is equal to number of protons plus neutrons of an element. The atomic number and mass number of an element can be represented symbolically as A, symbol of the element, and Z. The atomic number and mass number of magnesium is 12 and 24 respectively. Isotopes and their application. In nature, it is found that many elements have atoms with same atomic number but different atomic mass number. Such atoms of the same elements are called isotopes. Carbon exists in two isotopic forms, 12C and 14C. The number of neutrons in isotopes is different and have same number of protons. Uses of isotopes. Uranium 235U is used for nuclear fission and production of energy. Number 2. Iodine 131I is used in the treatment of goiter, a disease of the thyroid gland. Number 3. Isotopes of some elements are used in the medical treatment of deadly diseases like cancer. Number 1. Isobar. There are a number of different elements whose atomic mass numbers are same. Such atoms are called isobars. For example, K40, Ca40 and Ar40 are isobars. Potassium, that is K, 19 protons plus 21 neutrons. Calcium, that is Ca, 20 protons plus, and argon, Ar, is 18 protons plus 22 neutrons.